Um, all right. So this is Junichiro Hagino or Itojun from IIJ, and I will be talking about the commercial IPv6 deployment in Japanese ISPs. So basically, I will update you about the status of Japanese ISP deployment of IPv6. So here is the outline. So first of all, I think I need to tell you who are we, and then I will talk about Japanese ISP status on IPv6 and why Japanese ISPs are so into IPv6. And then I will give you some hint on IPv6 backbone design and service design. Also, I will give you some customer profiles from our customer surveys, and also I will talk about some technologies and the equipment needs. So this is basically input to vendors. First of all, who are we? Just in case you don't know IIJ, IIJ is one of the very first commercial ISP in Japan, and probably still one of the biggest. And we are operational since 1992 in terms of IPv4, and 1998 in terms of IPv6. And we provide IPv6 connectivity services commercially since 1999. And we have two address spaces. One is sub-TLA from APNIC, another is PTLA from NG Working Group of ITF. And we are basically using 2001 240 sub-TLA1 in primary manner. And we started IPv6 tunneling services since 1999, and then introduced IPv6 only lease-line service, which should be added into your customer space when customer already has IPv4 lease-line starting 2000. And then we started IPv4 v6 stack lease-line services starting 2001. And these services are commercial services and not experimental services. By commercial services, I mean customers can call up our sales agent and then just ask for the form, and they fill in the form, and then some people from company will come to your office and install wires, and you're done. So that's what we do. And also, if there's a trouble, these customers can call our help desk for help about IPv6. That's what we mean by commercial service. And we do charge money for that. And we have some other IPv6 services, such as web server hosting for IPv6 with IPv4 and v6 stack support, and data center with IPv6 connectivity. And also, we do manufacture routers because in 1999 there was very few choices in IPv6 ready routers, so we made one ourselves. And also, we do some consultation to help people design IPv6 network for their company or their university. And we also participate and contribute to CAME effort and IETF effort. And just in case you don't know CAME, CAME is IPv6 stack for BSDs, and it is used in FreeBSD and macOS 10 and ExtremeWare and some other routers. So this is what we do in IPv6 domain. And ISP situation in Japan with respect to IPv6 is like this. There are more than at least five ISPs offering commercial services. Some of them are doing tunnels, some of them are doing lease lines, and the NTT Communications recently introduced the DSL services with their stack. So they offer single dynamic IPv4 address and static /48 IPv6 address. So in terms of IPv6, so their service offers a complete static IPv6 address. And there are more than 25 ISPs offering experimental services. Their level of commitment differs. Sometimes they just ask special customers to do IPv6 experiment with them. And in some cases, they they do experiments more widely. And there are more than 5 IPv6 IXCs operational in Japan, both commercial and academic. And one of them, one of the biggest is NST IXP6, which is operated by WIDE. And more than 45, I guess it's over 50 right now, ISPs are participating at NST IXP6 and the exchanging traffic over there. And I have tried to count the number of IPv6 sites, meaning maybe university, maybe company, maybe somebody's house. So, and on my count, at least 1,500/48 sites are in Japan. So, and this doesn't include the number of 624 sites in Japan because 624 sites are very difficult to count. The 624 is basically automatic tunneling technology, so we cannot really count these 624 sites. So anyway, there are at least 1,500 IPv6 networks in Japan. So why Japanese guys are doing it so early? For us, actually, this is not early at all. Japanese government actually give us some tax deduction program and some funding, but that's not the real reason. The real reason is that we believe that ISPs need to act proactively rather than waiting for customers. By the time customers start asking for IPv6, we need a working backbone, so we need to be prepared. And we need to gather operational experience much earlier than customers. Otherwise, we cannot help customers. Our job is to help customers do networking. So we need to gather operational experiences much earlier than customers. And we would like to break the chicken and egg problem between customers and us. For example, if customers do not ask ISPs to do the IPv6 services, ISPs do not do that. If ISPs do not do IPv6 services, customers cannot buy that. So there's a chicken and egg problem. So somebody has to start first. So in our case, we went ahead and started first. And by starting early, we can earn more experiences earlier than others. And also, IPv6 creates a lot of market opportunities. For example, IPv6 is seriously considered by cellular phone guys. They are trying to avoid the manufacturing telephone switches, and they would like to switch to the IP cellular phones. So these guys are serious about IPv6, and when they start the services, we need to be prepared. And also, guys like Sony, PlayStation guys, and some other gaming guys are really serious about IPv6. So we really need to be ready for IPv6. Otherwise, we will lose potential markets or potential customers. So our mission, I believe our mission is to make IPv6 the default IP protocol. That is our mission, I guess. So here's the diagram of IIJ backbone in IPv4. So we have some network in Asia and Japan and the US, and we are using pure IP backbone, no MPLS, and we have 3 gigabit BS between Japan and the US. And this is a diagram inside United States. And this is IPv6 backbone for us. We operate separate backbone for IPv4 and IPv6. And our IPv6 backbone connects to 7 IXCs. And we pair natively with other 45 or maybe 50 ASs at these locations. And the reason why we deploy separate backbone is because Cisco software is separate for IPv6. And we use S-Train software for IPv4, and we need to use T-Train software or ST-Train software for IPv6. So we need to use separate Ciscos for the backbone. And we cannot really put T-Train software to our IPv4 backbone. If we do that, I will be killed by our operation people. We cannot compromise IPv4 SLAs. So we're really waiting for more stable IPv6 and IPv4 their stack routers. And these dashed lines are tunnels, and these dead lines are leaf lines. Okay, here are some hints about backbone design. Keep in mind, we need to provide simple and robust and scalable network. So that's all. So we do not need to do fancy things. So for the IPv6 and before desktop routers, you can use iOS 20.2T images and all the recent JunoS and the Hitachi routers, NEC routers, Fujitsu routers. So you can use them at ease. And they come with IPv6 on by default. So it's a matter of configuration for you. And at this moment, when we measure traffic at the exchanges, traffic volume between IPv4 and IPv6 is like 800 to 1. So if you have like 10 gigabps for IPv4, I guess you will have 1 meg for 1 meg or 10 meg for IPv6. So PC routers like FreeBSD, NetBSD can easily handle traffic of today. So you can start small, but you will eventually would like to switch to the other routers like Cisco, Juniper, whatever. And routing, for routing we use at this moment BGP4 Plus over IPv6 for IBGP and eBGP, and also RIP-NG. And OSPF v3 is still in infancy, and the vendors are trying to stabilize it. So we are not ready yet, but we would like to switch to OSPF sooner. And we do filter bogus routes by using RFC 2772 rules, and so we do not emit any 6/64 or 128 routes. And links, we use configure tunnels within our AS only, because long haul tunnels are really bad for your stability. And we use PPP over IPv6 over PPP, and IP over Ethernet, IP over ATM, what have you. And so we do not need to design a fancy network. We need to design simple network. And so the question maybe is whether we should deploy separate backbone or unified backbone. If we deploy separate backbone, you don't need to modify IPv4 backbone. So no SLA compromise for IPv4 services. So IPv4 operators will be happy. But if you deploy separate backbone, you will have more equipment to babysit, and you will get separate bills for these lines. But the advantage is you can use IPv6 router with data firmware if your IPv6 SLA allows. And for unified backbone, we really need to have stabilized IPv4 and IPv6 Dell stack routers, and we will have less equipment to babysit, and we will be able to use single leaf line for both of them. So at this moment, I think separate backbone makes sense, and in the near future, we would like to switch to unified backbone. And tunnels are a little bit complicated piece of the world. Service design. First of all, connectivity services. You can first start providing tunneling services, IPv6 over IPv4 tunnels to your customers. One BSD Unix box can terminate 1,000 tunnels at ease. So you can start by Unix box, single Unix box, and you can terminate customers' tunnels by that box. And then you will go ahead and then start these line services, and then you can do DSL. And if you do data centers, you can do data center racks. And the question is charging model. How do you charge for IPv6 services? By traffic, by bandwidth? I don't have the answer. It's up to you. And if you are running IX, of course you can do IPv6 IX services, because you just need to provide your switch fabric for IPv6. And I think application and hosting will be an interesting field, because web hosting capable of doing IPv6, email messaging voice over IP capable of doing IPv6 would be very interesting. And I think there are huge markets for service and network integration and consultation for deploying IPv6 network, because very few people have clues in deploying IPv6 network. So consultation would have a big chance. And here is a breakdown of IPv6 customers in our network. 50% are SOHO, 50% are corporate, and among the corporates, 30% is ISPs and the 25% are system integrators. And we have more than 200 customers already. And 10% of them are EDIS lines and 90% of them are tunnels. Honestly, we don't know what customers are using, really. But the SSH, FTP, IRC, HTTP, SMTP, NNTP, these protocols are very common over IPv6. And customers do depend on our IPv6 services. So it's not a research store anymore. And we cannot really stop IPv6 services. And we do monitor IPv6 services and the IPv6 platform 24/7. And here are some input to vendors, and we are really waiting for stabilized IPv6 implementation, and the multicast support for IPv6 and OSPF v3, and IPsec protection for routing protocols, and also we are waiting for MND snooping layer 2 switches. These are very important portions for IPv6 services. And in the future, we would like to have integrated IPv4 and IPv6 platform, but we are waiting for router vendors, so please hurry up. And I think, yeah. So what kind of technologies are important? And robust and stable routers, that's very important. And wider range of IPv6 support, and customized devices and DSL aggregators need IPv6 support. And we need, as Paul mentioned, we need root DNS servers and CCTLD servers to support IPv6 transport to allow deploying IPv6 dominated or IPv6 only network. And we really need more educational material for IPv6, like books, whatever, to educate our operators. And that's all. So here's a summary. So I think ISP should deploy IPv6 now, if not yesterday. So, or you will lose your potential market or potential customers. And you do not need to deploy function IPv6 network. You need to keep it very simple and robust, and that's a very important point for the internet. And I think ASP or integration services have a lot of new chances. So if you are doing consultation, you have lots of chances. And vendors still need to do more, I think, stability and for decentralities. And we hope to deploy IPv6 and IPv4 integrated backbone sooner. So I really would like to cooperate with vendors to stabilize their implementation. And here are some URLs. If you would like to check them out later, and so do so, please do so. That's all. Thank you very much.